So Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to all. So I hope that you guys have meet with each other. Okay, first time I meet with Saddam. Okay, Saddam. So welcome to Malaysia. Welcome to Malaysia. And then I hope you have a good study here in Malaysia and make friends lah with the local students. Okay, so because I believe I understand the feeling of foreign student lah. Yeah, I've been studying in Japan for 5 years. So it's not going to be a good experience if you don't have friends in Malaysia lah. Especially if you don't make friends with the local people. Okay, don't just be with your people, but be with the local student also. Okay, so that you have a great experience lah, the study in Malaysia. Alright, so I'm just going to recap a bit since Saddam just come in. So yesterday, actually you have already completed. Actually, most of the topic have been covered until part 3. Okay, part 2 and 3 was online. So you guys, what you guys did was you refer to the recording that I have, and then you do the assessment lah. Okay, and then submit assignment. So there is one assignment that you need to submit, which is assessment 1 based on the part 3 electrical and electromechanical system. Okay, the deadline was updated to 1 December. And then for part 4 fluid and thermal, I have informed yesterday that this is I omitted. I don't cover it in this semester cohort since I think it's too much for the system dynamic, because when you have the rigid body, mechanical rigid body, and also electromechanical, and also state variable, it will be too much to cover everything. But of course, you can always look at the notes that I have on fluid and thermal, and also if you want to review the video, I have also video in my YouTube lah, so you can just go and search it. Okay, so yesterday what we did was on part 5. Am I talking too fast? Huh? Too fast? Too fast? Can you understand?
Yes.
Okay. Try to adapt. Try to adapt. So yesterday what we did was on the block diagram. So I did a recap on the mechanical system. Okay, a bit on mechanical system. So I discussed about the first order system, one where we have one mass system, and then we have two mass system. And then how do you actually do the modeling? So I did a recap on that on the first few 1 hour, and then recap on also an electrical system. So reason why I did a recap is that both of this modeling, mechanical and electrical system, will be used in part 5, which is state variable models. So whereby you are going to derive the state variable based on the modeling that you did in part 2 and 3. Okay. So let me just sit there. I am a bit tired actually. So you just look at there. Okay. So what we did was I recap on what you have learned before during undergraduate's bachelor degree. So you have a transfer function, how you actually simplify the transfer function. Okay, you have a feedback, how do you simplify it and get one transfer function lah. So basically you have a pick off point and also moving it left or right. So we did an example. First example, get the transfer function for the whole system based on input and output. And then also this is exercise that you take home, okay, as your exercise. Very simple actually. You have done it during undergraduate, so just a recap on that. If you cannot remember, then you can always go to YouTube and try to search for how to do the simplified plot diagram. Okay, to study again lah, because I know some of the topic maybe you have learned it during your second year or third year study during undergraduate, and you cannot recall how to do it. Okay, so you just go to YouTube and find related videos lah. Okay. And then we go to state variable models. So state variable model. So we did. I explained how we can actually define the state variable based on the input that we have. So we define, and for state space representation, I didn't bring the pointer. So for the state space representation, we have two equations basically. We have the state equation, okay, which is denoted by x dot, which is the derivative of input lah, x. So x 1 dot, x2 dot, and so on lah, depending on how many input you have. And then you have the output equation. So the state equation will be depending on the input x, and also the x is the variable, and also on the input. And for the output equation will be depending on y itself lah, output. Y will always depend on the input that the state that you derive. Okay. So and then we did some examples. So I think you can just go through, remember those who attended yesterday, no problem lah. I think still fresh in your mind. But for Sadam, okay, Sadam, you need to watch the video. But bear in mind, state variable actually you have learned it during undergraduate also. So maybe a simpler block diagram. Okay, so we actually stop at this one was take home, right? Do it on your own at home. I know we have the rotation and the mechanical system also. You do it as a take home exercise. So we go to part 3 today. 3, 4, and 5. 5 will be on the assignment. So after you have defined example the state variable, okay, yesterday, okay, what you did was, okay, let me just open back what we did yesterday. Okay, so we did on the exercise 3, state variable, we have two mass system, and then it's connected to m1 is connected to a fixed value, so it has a damping coefficient d, and then you have also m1 connected to m2 with k value. Then you have a force here. F is the input. Okay, reason why, like I said, force is the input. So we have a system whereby, recap again, if you cannot remember, because you just came in. So yesterday I used a simple example. Luckily I had this teaching. It can be a string. Okay. So let's say that okay, you have this one, and this is a mass. Okay, this is a one mass system. This one, one mass system, whereby this one is fixed up inside as fluid fixed. So it's fixed by my hand here. So what you do is that when you pull this, what happens is that the mass will retract back to the original position. Okay, so when you push it, then it goes back. So we have a spring, of course we have a spring over here because it's go back. What else we have? We have the mass. So mass can be anything. Mass can be different variable. Okay, for example, the cylinder and so on. Okay, and for the case of this, we don't see any damping coefficient basically. But you know that when you pull this, okay, when you pull this, is that I'm actually giving the input. I'm the input. I'm giving the force. So I'm giving force. So that force will be input. Okay, it's not an output, it's an input. So it's going to be an input. And when it track, it will go back slowly. Okay, assuming if example in a control system subject in bachelor degree, most of the time your lecturer will tell you that okay, we have a mass system, and then we omit the friction. It's frictionless. Means that if it's frictionless, most of the time is that the system will be moving. Okay, because there's no friction after you stop it with your hand. Okay, so it's going to have no friction. But for this case is that you see in reality, you have friction. The friction is friction between mass and the table. So you actually have a damping coefficient. Okay, so that's why when you do a model, then you have a damping coefficient here. Okay, sometimes you also have a damping coefficient on here, okay, other than this one. Okay, so you have a damping coefficient over here. Then you also have the damping coefficient here. For example, C1, Another one is C2 for the friction. Okay. One thing is that yesterday I told you guys about the door. The door is also a system whereby you have a one mass system. So this door is mass. The door is a mass. Then you have a spring system because it's flow back, and then you have a damping coefficient whereby in the spring system because it's flow back slowly. Okay. So because of this, and then this is we don't have the friction over here like this because it's hanging in. So maybe friction will come from this hinges. Hinges is a friction because it also has friction. So you can make the model of this door more complicated if you want to take in this friction. But assuming that we just omit it, then we do the modeling based on this door and also this friction history. Okay. So back again to this example. Okay, so F is the input. Okay, and what is the output? The output for this, because we have two mass, when we pull, these two mass will be moving, maybe with different displacement. So that's why we have x1 and x2. Okay, so based on that, we want to come out with the free body diagram first. How we come up with the state variable model is we have this call it as the SOP, okay, somehow SOP so that you understand how to do it step by step. So draw first the free body diagram of the system. So you draw first, okay, and then you define a variable, new variable based on what we have right now. So we define it based on the variable that we have. And for the case of the variable that we have, we know that we have two displacement, okay, x1 and x2. So we can just take that as two displacement. So we use x1 and x2 as the state variable. Okay, so we want to make it as the input. So that's why for the second part is that we define this new state variable. So we define it as x1 equal to x1, z1 equal to x1, and then z2 dot equal to x1 dot, and z3 equal to x2, and so on. But like I said, there's no one solution for this. There's no one solution for this. I've mentioned yesterday, okay, sometimes, okay, you might want to define it as z1 equal to x1. Okay, this is normal, and we start with 1, 2, and so on, right? But, and then when we define z2, maybe you start with x2. Okay, so this is another option how you define the state variable. So there is no fixed answer for when you define it. It's up to you how you define it. Okay, so when we do this, then z3 will be x1 dot and z4 will be x2 dot. So when we have this another set of variables, state variable that we assign, then of course this will be different value. Okay, different value, and your answer over here will be a bit different, and you will get the answer for state equation and output equation will not be the same like this. Okay, it will depend on the variable that you defined earlier. Okay, so might be when you do your tutorial, okay, I have a set of tutorial that I upload in YouLearn. Okay, it's under part in YouLearn. Let me just show to you. Okay, in YouLearn, I have updated a few info. Okay, resources and class recording. This is the notes, and then tutorial exercise. Okay, part 1 to 5. Okay, so this one is a tutorial that I mentioned to you guys yesterday, whereby to prepare for your midterm exam and final exam. Okay, for midterm exam, it's up until the one that will cover in midterm exam will be part mechanical modeling and also electrical modeling. Okay, not including the state space representation that we will learn yesterday. So only two. So means that 2 questions. One will be question on mechanical modeling, another one will be on electrical. And then so for the tutorial, okay, what I want you to do, even though in the tutorial included the state variable, so you can do it you can start doing it, the exercise of getting the solution. And maybe you different, some of you guys will define state variable differently. It's okay. So just compare your answer. So when you compare your answer, if your answer is not same with your other friend, then you need to check step by step lah. Where is the thing that make it different? Okay. So different state variable doesn't mean that the answer is wrong. Okay, it's how you define it. So under this step also, I have updated by I compile every video recording according to parts. So part 2, and then part 3, and then yesterday class was also updated here, part 1, part video 1, right? So you can just I didn't record it from the beginning. I forgot to record it. So in the middle of it, then I remember. Then I only start to record it halfway through. Okay, but it actually was at the beginning of the topic lah. It was, I think, it was starting from here. I start to record it. Okay, so the back there not that important lah. So this one is okay, cover everything. Okay, so and now, okay, so what we are going to do is that we are going to learn how to convert from state variable or state equation to transfer function. Okay, and of course yesterday, okay, you also come up with what I thought teach you guys is that let me check yesterday transfer function. Okay. So what we are going to do is that we are going to convert this, okay, from state equation to Laplace. So how do you come up with this equation is that, let me just derive it. Of course, you can memorize it if you want, but as an engineer, okay, you want to know where it come from, right? Most of the time, where does the equation come from, right? So it's like a simple question by my student. Last semester I taught signal system, and then I was teaching Fourier. I think it was Fourier series or Fourier transform, okay, and then even Z transform lah. And you know, Fourier series, Fourier transform, Z transform, we have the table to refer to when do conversion, So, but before I go and teach them to use the table, I will always derive first and prove that, oh, this is the same with the table. And then there was one question by student. Why do we need to derive everything when we can use table to actually get the answer? Well, you use calculator to calculate. For example, it's the same reason why you use calculator. Calculator is a tool, right? So the table for Z transform, Fourier transform is a tool for table that it's very fast for you to get the answer. Okay, but if you don't learn the basic, for example, if you don't learn the basic of multiplication, okay, 12 times 12, we don't know the basic. If you just press it, 12 times 12, oh, 144. Is this correct or not? How do you know it's correct if you don't know the background of how to do the calculation? Okay, so the reason why, okay, in undergraduate, even though you are given table, tools and so on, you still need to know the fundamental behind it. Okay, I was discussing with my husband this morning about dynamic system. He was asking me yesterday, what do you teach? He's a manufacturing lecturer in FKP, teaching manufacturing. And then yesterday, what you teach? I was talking about, okay, I was teaching about this now. You know, the discussion at home is about class. He talking about modeling, and then he is not in electrical background. Of course, he's a mechanical background, mechanical background also actually learn about modeling. Okay, they learn about modeling. And then I was talking about blah blah, and then his face was blur. Yeah lah, long time ago what he learned about that again. Okay, and then so he asked me, where is the application for this? Okay, so I keep on ranting about, oh, this one you can use it in modeling of an engine, and then he cannot comprehend what I was talking about. How to actually model an engine from this? Okay, how can you do that? Okay, can you get the idea why when you start doing modeling from the basic, then you can only understand the complicated application. Okay, an engine, you have cylinders, right? Cylinders is tengok tak? I don't bring the. Let me just draw it here. Okay, you have a cylinder, right? Okay, most of the time the cylinder will moving like this. Okay, it's fixed, correct? So the cylinder is moving upward in an engine, right? Can you remember? Okay, in introduction to mechanics, I'm actually teaching engine part for mechanical mechanism. So you have the slider and crank mechanism. Okay, basically slider and crank mechanism. So what happens that this mass will be moving up and down based on how you rotate this slider and crank mechanism. Okay, so imagine that this is a mass fixed to the base. Okay, so it's moving up and down. Okay, of course, if you want to model this slider and crank mechanism, is going to be complicated. Let's say that you model it as a spring just now. Okay, so you will have a similar system like this. Similar system, just it's in the Z direction. Okay, so having said that, this is only one cylinder in an engine. An engine minimum cylinder, how many cylinder? 3, right? 3. But some right now turbo we have 6. Okay, turbo engine, 6 engine. So before you can model 6 engine, model 1 first. Then you just need to multiply it to 6. And then how do you model that 6 engine into one transfer function? So, okay, so you know the technology right now is that it's up to right now we can control the engine motion. Okay, motion, how it goes up, crank up and down. So, but you are going to become an engineer. So you need to know the fundamental behind it, so that later when you are asked to do a modeling of a system, then you know how to do it from zero. Okay, so back to this. Where is it? Okay, so we have, based on this equation, is it large? My screen is a bit small. Okay, based on this equation, let's say we take this Laplace. So we have, don't look at up here, look at the one that I'm writing. X dot, we have AX plus BU, and then we have Y equivalent to CX plus DU. Okay, so if we take Laplace transform, okay, Laplace transform, then what you have is that SXS equivalent to EXS, okay, plus BUS. Okay, and then whatever is here but I'm going to write it out. So from Y you get Y S equal to CXS plus DUS. Okay, so if you see here, okay, from this equation, a transfer function, what do you want to actually get the equation of the for a transfer function? You want to get it as Y, of course Y. You want to have, you have GS, you have input X, then you have Y. From these two equations, state and output equation, what do we have right now? You have You have y, right? You have y. Y, okay. You have x. You have x over here, yeah. You have input, yes. Okay. You have x over here. But do you have x dot? No, right? So you don't have x dot, whereby this is s. No? Okay. So how do you actually go by this is that, okay, when you want to solve for this, okay, we want to solve for xs. Okay, so you can actually elaborate on this. Okay, you have xs, okay, and then you have s minus a, right, equal to b u s. Correct? From this equation, this one, wait, this one, combine it. Okay, so you have xs, s minus a equal to bus, right? But in matrix form, you know that A, B, C, D is in matrix form. Whereby matrix form is that you have, for example, like this, nah, A is a 2 by 2 matrix. Okay, so, and you have only S here. S is in terms of matrix form, you cannot use it. So you need to multiply it by the identity. Okay, identity form. So when you multiply by identity form, then you will get the same equation like this. Okay, Si minus A, okay, Bu. Right? So, knowing that, okay, then now you can actually answer or get the equation for y. So you want to substitute, let me just take that, this one, xs, okay, substitute into this value. Okay, so if I were to actually rewrite this, you have what? Si minus a, inverse lah, inverse, because we take it down there, and then bus. Right, so then we substitute this into this. Okay, so you get C, so basically C, Si minus A inverse, okay, Bus times Dus. So you get the equation in terms of output. Okay, so you get the transfer function, basically y equal to output. Normally when you have a system, what you need to look at is you want to get the output in terms of the input. Okay, so by having this, you can actually get the equation. So okay, so this is just a bit about explanation of the identity matrix just now. So identity matrix meaning that if you have a 2 by 2 matrix, okay, if you have a 2 by 2 matrix, so this is 2 by 2, meaning that instead of 0 everything, you have a identity matrix like this. Okay, and this will be 3 by 3, whereby you have 1 in the center there, and then this will be 4 by 4. Right? So this will be fixed. Okay, when you have a 3 by 3, 2 by 2, or 4 by 4 matrix. So let's look at a system whereby this one is okay. This one is just a little bit an explanation about why do you want to use the equation. So most of the time, if you remember during your undergraduate bachelor degree, you actually calculate for characteristic equation. So how to do that is that by calculating the determinant Si minus A. Can you still remember how to do that? 2 by 2. Can you remember? Dia ada macam silang semua kan. Have you done 3 by 3? Kan, kena tutup sini, ini. So complicated lah. But you still need to know lah. But have you done 4x4? Impossible lah, I think. Impossible a bit. Normally people will directly use MATLAB. Okay, to get the value for from A, B, C, and D, and get the transfer function using MATLAB coding. Okay, so why do you actually calculate for this characteristic equation? Okay, so the aim is actually to check for stability of the system. Okay, so this one I'm not going to teach you. Later, Dr. Khairi will continue on this. Okay, so my topic will cover only on modeling of systems, mechanical system, electrical system, and then up until state variable form lah. And then Dr. Khairi will continue on with whatever you have right now. We have a system, but maybe he's not going to teach you on modeling even. Okay, so bear in mind that when he give you a transfer function, meaning that it already derived from a system. Okay, so maybe the question will be asked like, okay, find the stability of the system when blah 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 and so on. Okay, so how to get the poles value. Okay, when you want to reach this performance characteristic. Okay, so let's look at example. Okay, we take this one example whereby we have a state space model 2x2 matrix. Okay, so we have A, B, C, and D. Okay, find TS. TS it's basically the input over output. Okay, output over input. So you can find it using this what we have just now. We derive it. So let's do this together. Okay, I hope everybody have pen and paper. In the notes, do we have the answer? Oh, we have the answer. But anyway, just don't look at that yet. We do it together in front. Okay, so so what we need to do first is, okay, let's say that this is continuing from what we did yesterday. Okay, you are given one system, one mass system, and from this one mass system you get a 2x2 matrix. Okay, after you define the variable and so on, so you get this state space model. So state space model will consist of this first equation. We call it as the state equation, and then we have the output equation. Okay, so what we want to do is, first of all, when the question is that, okay, find the TS, or TS is actually G lah. Okay, so you have the TS here. Okay, you have the input U, and then you have output as Y. Okay, so basically find the transfer function of the system. So first step is that take out the value that you have, or from here is that we just directly key in into this equation. So let's say that I'm going to denote it as GS. Okay, so GS equivalent to C, just write it out again, SI minus A inverse 1 B plus D. Okay, let's look at the value. What value do we have? Do we have C? C value here? Yes, right? We have C value here. Do we have A? Yes. Do we have B? Do you have D? Huh? D. 0. No value lah, 0. So we just put directly 0 value lah. Okay. So what you're going to do is that to start doing the inserting all the value A, B, and C into this equation. So start with C first, since we have C here. So C, so we have 2x2 matrix. So 1x2 matrix. Sorry. So we have 1 and 0. Okay. And then we have SI minus A. SI is what? Is a S multiplied by the identity matrix, right? So identity matrix by 2 is how just now? It's 1 0 0 1. Okay, multiply by S, so you get S. Okay, so you have here S 0 0 S. Okay, minus A, so you have A here, so you have 0 1 minus 2 minus 3. Okay, inverse 1, the whole thing you want to inverse it, multiply by B. B is 0 and 1. Okay, so this is direct, so we try to write it out. So S minus 0, we have S 0 minus 1 minus 1, 0 minus minus 2, 2, S minus minus 3, S plus 3. Okay, inverse of that. Okay, just for the sake of it, so inverse of it, and then 0 1. Okay, so for the case of inversing of a matrix, so how do we solve for it? So let's say that I'm going to define E as the equation, E, and then we have A, B, C, D. Okay, and then, so let's say that we want to inverse E. So we want to inverse A, B, C, D. So how we do that is that we use the equation 1 over determinant of E. Okay, and then multiply by, swap A and D. B, A, C and B stay, but we multiply it by minus, minus C minus B. Okay, so basically how we get the determinant is that A minus D, so it's A D minus B C. Alright, so D minus B minus C A. Okay, so let's do this. You have 1 0. So we want to get the determinant value, right? So 1 S multiplied by S plus 3. So S plus 3 minus minus 2 plus 2. Okay, please confirm that I'm correct, or if I'm wrong then please correct me. And then you want to multiply it by this one, right? So you need to swap it. So you have S plus 3 S, you have 1, you have minus 2, right? Then multiply it by 0 and 1. Okay, it looks complicated, correct or not? Yes? Anything wrong?
I think there is a change between 1 and minus 2.
1 and minus 2. Which one?
Yeah, here.
This one. S plus 3, S plus 3, S 1.
Plus 2.
Minus 1, 1 and minus 2 kan? Correct? Is it correct? Correct kan? I think it's correct. Oh, why you think it's incorrect? This is the original. Okay, original. For this, we need to swap this. S and S plus 3 swap it. Okay, and then this value minus 1, remember here? Yeah, sorry. Remember here? B, we need to add minus. Minus, and C, we need to add minus. So we have add minus here, so become 1. So this 2 become minus 2. Okay. Right, so let's try to solve this one first at the back here. Okay, so if you have, okay, let me write that out as 1. Okay, if I expand it, I have what? S squared plus 3s plus 2, right? Okay, let's say that we are going to multiply these two. Multiply first these two metric at the back. So you have s plus 3 times 0 is 0 plus 1. So you have 1 minus 2 times 0 plus s. So s. Okay. So is it correct? Almost, almost done. So now we continue to expand it more. So you have 1 and 0. For example, we want to settle this first. So 1 times 1, this equation, plus 0. So we have 1. Of course, we have s squared plus 3s plus 2. Okay, and then multiply it 1 and s. So what you have here is, what do you have? What do you have? 1 over 1 plus s over s squared plus 3s plus 2. Is it correct? Let me just check. Macam salah je sekejap. We can actually multiply it first, okay. This one plus this one, since it's a multiply, so 1 times 1, 1 times 0. So actually multiply by 1. So this is one is a final answer. Okay. I missed that. We have the one at the back here. Okay. So multiply that, you get the answer. So we actually get the transfer function GS. Okay. So let's say that okay, this one is one example that you are given this equation. Okay, let's say that, do I have an example? Okay, we use this example. Mass, spring and damper. Mass spring. Okay, I'm going to add one more, which is a damper. And let's look at one example that we can do. Okay, we define it from early steps. Okay, let's say that we have this. Okay, so we have a spring, also, a damper also here. So we have the input as F. Okay, we have X here. Okay, then you have K and then you have B. So yesterday, did we do this exercise? We did its exercise. Did we do this exercise? No? So macam ada. I just want to take the value, the A, B, C, D value. Let me just look at it. This one, kan? This one, right? Okay, we define it. This one, right? So you have A minus K again, minus BM. Yeah, this exercise. So we are going to use this value. This value. Okay. So let's say we take this value whereby you define it from this equation. Okay, so after doing yesterday exercise, okay, you get the state representation. Okay, means that the state equation and also the output equation. But in the question, they ask you, okay, find the transfer function of the system. Of course, you can have to, you can actually get the transfer function without actually doing the state representation, like I said yesterday. So, but right now we have also, you have already the state representation. So, example of complex system, maybe they give you a state representation. Okay, a complex one, 4x4 matrix. So calculate for the transfer function. So what you can do is that you can actually use the equation. Okay, the equation in the case of just now the example, just check. Previous example, they give you a value, so we cannot really use that. So let's do it from the solution, solution using this equation. So we want to find GS. Okay, C S I minus A inverse 1B plus D. Okay, BD, you don't have any value. You have A here, B, C, and D. Okay, so let's do this quickly. Okay, so C 1 0, SI, okay, S minus 0, S minus A, 0 minus A minus 1, okay, and then you have 0 minus K over M, you have K over M, and then you have 0 minus K over M, so you have B over M. B, you have 0, 1 over M. Okay, and multiply, okay, n plus 0 lah, basically. Okay, so can you, I think I missed one value, S, That's the problem when you do this way, So you actually have S minus 0, S plus PM. Okay, I missed that. Okay, so confirm your answer. Okay, you have 1 over M. Okay, so let's do this. Okay, I'll give you 1 minute to do it. 1 minute to get the determinant over here, the inverse of this matrix. So try to using, just now we have E, right? And then try to use minus 1. So the reverse of that. So the equation for that, use this equation. Okay, why do most of the, if you see in normal books and textbooks, they will leave the value for K, B like this. They don't give you a value. Reason why is that when you can insist on K, the value for K, B, and M can be varied. So you might want to look at, oh, you have a mass value which is going to increase it. So you can actually tweak the value from here. If you are given only directly the value inside, so it's impossible for you to actually change it later on. Okay, so means that you get the function in general like this. So you later when you do the analysis, you can actually change the parameter k value to different value and so on. Okay, so that's the reason why it looks a bit difficult or complicated because you leave it in these terms, but it's very useful later when you do analysis. Okay, so did you get the answer? Let's just continue. So you want me to explain how you get the answer? You want me to derive it? Okay, the final answer is ds. Okay, if you get it, then it should be okay lah. Okay, m squared plus bs plus k. Okay, did you get the answer? ds equal to m squared plus bs plus k. Dapat jawapan tak? Huh? Salah? Huh? Sadam? Did you get the answer? Not correct. Which part is not correct?
I will check.
Okay, so let's do it quickly then. We try to do it quickly. Okay, so we have 1, 0. Okay, this is the similar lah. And then we need to do the determinant, right? So 1 over S multiplied by S plus B over M. Okay, and then minus plus K over M. Right? So this is first one. Okay, multiply by S plus B over M. S 1 minus K M. Okay, 0, 1 over M. Okay, you got the answer? S plus B minus K 1 over M. Yeah. Okay, so what you can do is that you can expand this if you want. Okay, but now we settle this first, right? We settle this first. Okay, so you have 1, 0. 1 over S squared plus B over M S plus K over M. Right? Then, okay, we settle this one. Okay, settle this. So we have S plus B over M 0 plus 1 over M minus K over M 0 plus S 1 over M S, right? Very bad handwriting. 1 over MS. Okay, so you get something like this. Then you settle this with this. Okay, so you get 1 multiplied by 1 over M, right? So 1 over M multiplied by this one, multiply 1 over M plus 0. So 0. So this whole thing is multiplied by S squared plus B over M S plus K over M. So you get the answer is, okay, is this correct? Then you get, well, you need to bring that up, right? So you get multiply this whole thing, multiply, if you want to do it, you can multiply everything with M over M. Okay, if you get confused and multiply everything by M over M, then what happens is that cancel out. Okay, so you have, and then also this one also cancel out. Okay, then you get 1 over M S squared plus BS plus K, right? So this is the answer. Okay, so which part was wrong just now? Which part?
Which is one was sorry.
This one. Oh, okay. So make sure, maybe need to check again lah. What double check once you write it down, and then double check again if it's correct. Because if we go down ahead and then you get the wrong answer. Okay. But as you can see, basically when you have one mass system, most of the time you will get a second order system like this. Okay. So this will be the answer, and you can verify your answer is correct or not. Okay, so you use MATLAB. This one is a coding that you can use in MATLAB. So A is the matrix ID. So you have 2 by 2 kan. So 0, 1, minus 2, minus 3. So you can try to do it at home. When you run it, then for example, I define the system as system 3 lah. So if you want to define it as system 1, then just put it as 1 only. Okay, so and then this one without 3 lah. So everything is system only. System equal to SS is state space. State space A, B, C, D. So before you can do this, then you need to list out first what is the variable for A to D. And then you want to convert it from steady state to transfer function. So transfer function system. So transfer function system. So if you run it, okay, example, I already run this just now. Okay, you will get your answer. So what you can do is that as a verification of your derivation, your manual derivation, you can check it with MATLAB if your answer is correct. Okay, so of course in MATLAB, if you don't have a value like this, you have only value, right? 0, 1, minus 2, 3. So you can change it with a variable b, m, and minus k. So and then you can still get the transfer function. Okay, so that will be the first example just now, example 7. So let's look at one example whereby we have a circuit, because yesterday we didn't cover any circuit yet. So today we will cover on a circuit, okay, a one loop circuit. So let's do this. Okay, okay, so before we can actually, okay, the question is that, okay, get the transfer function from the state equation, but we don't have yet a state equation, because yesterday we didn't cover on circuit yet. Okay, so the first step for today will be to actually derive first the equation from the circuit. Okay, so first step is derive the equation, differential equation. Okay, derive the differential equation of the system. Okay, so like I said, before we can proceed, we need to find out how many states that you are going to derive. Okay, because later we are going to make it into states. Is it one state, x1, x2, or so on. So how you can actually, for a circuit, there's a tip, how you define the state variable. It depending on the energy storage that you can find in the circuit. So from the circuit, how many elements of energy storage? You have the capacitor, right? Capacitor, and also you have the inductor. Okay, 2. So automatically you know that you're going to have a 2 by 2 matrix. Okay, if you have another capacitor, okay, example C1 and C2, okay, so total will be 3. So you will get a 3 by 3 matrix. Okay, so for a circuit, it's much more easier for you to define. For the mass spring damper just now, it doesn't really according to that. It's going to be according to the displacement value, because when we have a mass, okay, and it will depend on the displacement. So when you have one mass, it's moving one direction. So if you have 2, then it's going to be a 3 by 3 matrix. Okay, so it's going to double up. So this one will be 2 by 2, that one will be 3 by 3 matrix. Okay, so let's start first. So before we proceed, we list out what variable that we have based on the Kirchhoff voltage law. So we can define based on just now we have the energy storage system. Okay, energy storage system, we have VL and VC. Okay, we know that we have that. So we can define the first equation, VL equal to L di over dt, and also we have VC, but of course we cannot use VC as equivalent because it's going to include the Q, 1 over Q. So we are going to define it in terms of I equal to C VC over dt. Okay, so based on this, okay, we are going to derive the equation. Okay, based on this derive equation, so we actually have two equations, basically two equations. And now we proceed to the state variable. So let's define, let's define. Let's say that, let's define the state variable. Okay, variable. Okay, we want to define it as S1 equal to, we have BC. Okay, and then X2 equal to I. Why I? Because if you see here, we can see that you have oh. So if you see here, you have I, which is related to VC, and also I is related to this VL. So we are going to derive it as the state variable lah. Easy for you later to come up with the state variable. So from here is that we get the x1 dot lah. X1 dot equivalent to VC dot. Okay. And then we have x2 dot equivalent to I dot. Okay, just follow me first. So VC dot, if you want to write it in terms of the time domain, you have what? VC you have dBC over dt, right? Which is equivalent to what? This one, right? Equivalent to this value lah. dBC over dt, dBC over dt. And then you have I dot will be this one lah. So how do you derive that? This is I dot. I dot. So if you derive it, you have di over dt lah, basically. Di over dt. Okay. Okay. So based on this, let's say, okay, we define first what's the output. Output for this case is that we want to have two output. Okay, let's say for this example, for mass system, we define mass system, the output is displacement lah, x. For these two mass system, we have x1, x2. For this example, I want to say, I want to define that the output is VC and VR. Okay, across VR lah, will be the output, and VC is across VR. Okay, so when we have that, we can actually define VC equivalent to x1 over here. So x1 and VR is basically I times I, right? Okay, B equal to IR, equivalent to I is equivalent to I2, x2, sorry, x2. So you have R times x2. So basically for the output equation, you already got the output equation. You completed the output equation just now. Okay, so okay, just now what we did was we just list out all the equation that we know we can actually derive from using the Kirchhoff law. So let's do a looping over here. Okay, V equal to VR plus VL plus VC. Okay, so and then based on that, I equal to VR plus IL di over dt plus, okay, BC. let's say that you don't change that BC. Why? Because remember, we define up here the variable already. Okay, so once you define the variable, then you don't need to change it. Okay, we keep it. Okay, so from here is that, okay, let's rearrange the equation. Okay, rearrange the equation. So if you want to rearrange the equation as I equivalent, why? Because we have this value, right, x2. Okay, x1 equivalent to we have here dvc over dt. Okay, so basically x1 dot, okay, we have here dvc over dt. Okay, so we want to rearrange the equation, this equation, take it out. So we arrange it, we become b 1 over r. Okay, I'm going to write it this way. So L sorry, no. We want to solve for that one, IR. Okay, let's say that do you see here the x1 x2 dot, x2 dot here, you have d1 over dt, which is this one, okay, so you can actually find what is the value for x2 dot. Okay, so let's di over dt equivalent to, okay, we have 1 over L, okay, L, oh yeah, correct, 1 over L B, okay, minus 1 over L IR lah, okay, so like this IR, and then we have 1 over L BC. Okay, so rearrange that, bring to the front, so you will get this one B L, take it down there, okay, 1 over L B minus 1 over R, okay, over L, and then minus 1 over L BC. Okay, so based on this, okay, if you substitute, okay, by definition, if you substitute the state space variable, okay, state space variable that you define up here, d over dt here, so you can rewrite it as ini, this one, okay, this is d over dt. So you have x2 dot equivalent to, okay, 1 over L B minus R over L. I is x2, right? x2 minus 1 over L BC x1. You might be wondering, what is V? V is what? Input, right? Okay, input. So input, okay, is V. So let's say that like what you did yesterday was, we define the input, right? So let's say that I'm going to define the input, okay? So this one, For example, y1 equal to vc, y2 equal to vr lah. Okay, because two output Okay, and then for the input is u equal to v lah as the input. Okay, so when you define the state variable, don't forget that most of the time, if you don't want to get confused, then define it earlier stage. Okay, so that when you expand it, then you don't get confused lah when you want to multiply it. So if you see here, okay, v is actually u, okay, because we define here, so you have u, right? So what we have here is that, okay, you have already the equation. Okay, so you have x2 1 over L, the only x2 equation. So how about the equation for x1 dot? x1 dot is this value, right? Okay, so that one will depending on this equation. Okay, I equal to c over dvc over dt. Okay, so you will substitute it, then you get x1 dot, okay, equivalent to I over c. I is what? x2, right? So you get 1 over c x2. Okay, do you follow me? Can you follow me? It's a bit confusing. Okay, but actually there are only two equations that you need in this variable. The first equation is this one. Second equation is this one. Okay, and then you start to define the state variable. And actually another equation is only this one, third equation. So based on this third equation, three equation, you expand it. Okay, so you expand from the equation number 3. Okay, expand, okay, from equation 3. Okay, substitute the variable, then you get x2. Okay, from equation number 2, okay, you expand it, then you get equation number 2. Okay, so basically compared to what you have learned yesterday is kind of easier than today, because today because of the equation itself, we have the two different energy storage system whereby we have L and C. Okay, so when you derive it, you will see that, oh, you have x1 dot, but this one is not a complete equation yet, not complete equation. So that's why you need to derive it from this equation. Okay, and also for x2 dot, you see that you have di over dt, and actually this is referring to equation number 1, right? However, you have is connected to VL. VL equal to L di over dt. So VL is where? VL is based on this third equation. Okay, then when you substitute everything, then you can actually find what is di over dt. Okay, so maybe my style of explaining is a bit go over here and then go back and so on. So maybe you can try to come up with your own SOP lah, how you can get the best way to actually derive it. But in the end, you will get one answer, which is this two equation. So you have these two equation. So what you want to do next is just substitute into the state variable equation. State equation, you have x1 dot x2 dot. Okay, so you have x1 x2 plus input. So let's look at x1 dot, where is it? Here. So you only have 1 over c x2. So x1 is 0, 1 over c. No input. For x2 is this equation. Okay, you will see that, oh, I have 1 over L for the input. So input 1 over L. And then what else? We have x2 minus r over L. So minus r over L. For x1, you have minus L, minus 1 over L. Okay, let me just check. Is my answer correct? Yes. Okay, so this will be the state equation. First equation. Remember, you have output equation. Okay, output equation. So output equation for this question, actually this question is not complete. I should have explained a bit. Okay, whereby given this circuit, whereby find the state variable when you have two output. Okay, across C and across R. Means that you have VC and VR as the output. Okay, so in a question, most of the time they will state which is the output that you want to derive. Okay, so and we have already defined the output just now. We defined that we have two output. Y1 is equal to VC, which is equivalent to X1. And also Y2 is the voltage across R. Okay, equivalent to IR. So we have Rx2. Of course, if I can make this more complicated, I have three output, whereby I have another output at across L inductance. So maybe based on that, you have Y3, you have another one. So your state variable for output equation will not be a 1 times 2 matrix, but it's going to be 1 times 3. Okay, so let's write there Y1 and Y2 equivalent to, look at your equation. Okay, your equation you have here. Okay, equation equivalent to where is the equation 0, y1 equal to x1 so x1 x2 1 and 0, right? There's no output, so 0. Y2 is equivalent to Rx2. So we have 0 and R. Right? So this one will be the represent the system as a state variable form. Is that right? Hello? Saya tengah ada kelas. Take 5 Take 5. Apa dia? Apa? Tak bayar bil? Kenapa? Oh, okey lah. Okey, tak apa. Nanti saya selalunya akan refer pada Selcom punya website. So, tak apa. Nanti kalau ada bil, nanti saya bayar lah. Kalau tak ada bil, saya tak bayar. Boleh? Tak apalah, nanti saya tengok. Saya tengah kelas ni. Scammer ke apa? Bila kita suruh kita cakap nak tengok refer website, kita dah letak. Scammer betul lah. Tapi masalahnya dia cakap bill free selama 2 bulan. Macam confused betul lah bill free. Boleh ke nak bagi free bil Celcom free? Saya punya postpaid. Takkan dia nak bagi free. Oh. Okay, so so continue. Okay, so we haven't finished yet. What we did was to actually come up with the state variable only. The question is that get the transfer function, right? Get the transfer function. Okay, so so let's do this example. Yeah, we are already 336. Can you try to do this example? Okay, and then on your own, because this is 2 by 2 matrix, and then check with MATLAB your answer. Okay, just check with MATLAB using the system, using this equation. This equation. Right. So and then there's another example, exercise 6, whereby I give you an example of 3 by 3 matrix. Okay, so in ULearn, I have shared to you, okay, because we don't have time, actually I need to stop at 4. So in the ULearn, under part 5, okay, I have linked you to one example of how to do matrix by 3 by 3. So they explain how to do a calculation. So if you cannot remember, just refer to this video and try to get the answer. Okay, for this, the answer is given down here. Okay, 1 over s squared plus 3s squared plus 2s plus 1. So you can also verify this using MATLAB. Okay. Okay, so these are some useful MATLAB function that you can refer. Okay. Most of the time, if you want to verify your answer lah. So I like to actually mention this to students, because when you do exercises, especially when you do the tutorial later on, so you don't need me to actually verify your answer is correct or not. You can actually verify it using MATLAB. Okay. So these are a few of the command from, for example, to actually plot from the matrix A, B, C, D to the system, and then to actually convert it from transfer function to the system. So you can try to use this MATLAB function. And these are some few examples. So if you want to just test your knowledge on how to do convert it to transfer function, then use this, derive it on your own, and then use the equation for transfer function in matrix ID just now, and verify your answer using MATLAB. Okay. And lastly is that from how to convert from transfer function to state space. So what we are learning is actually interchanging between when you have a transfer function. So how to get from the state space equation. Okay, example in chapter 2, you do a modeling, you get the transfer function. So can you easily get the state space model A, B, C, and D from transfer function? Yes, you can. Okay, so let's do this example. This is just a theory on it. So let me just explain. So as an example is that you have this transfer function GS. CS is the, where's my pen? Oh, here. CS, this is GS. C is the output. R is the input. Okay. So when we have this transfer function, we have B naught. We have. I don't like to draw using this one. Pen. So you have C, this one is numerator over denominator, right? Denominator. Okay. So you might have a value B naught. B naught is just a constant value. The constant value example is 2, okay, or 5, or 10, right? And then you have denominator in terms of the second order system or third order system. For this case, is third order system. Okay. So A0, A1, A2 is a constant value. So how to do this is very easy. So what you need to do is that cross multiply this value. Where's my, okay, cross multiply. Okay, when you cross multiply, then you have CS multiplied by down here, denominator, and then B0 multiplied by RS. So you get this equation number 8. And then you take the inverse Laplace, then you come up with this equation. Okay. then you're going to select the state variable. This one is where you did what you actually did last time, right? So how you can actually select the state variable is that by assuming that we have the third order system x double dot, right? So most of the time we know that if you have x double dot, then you are going to have a up until 3 by 3 matrix, is minus that one. So we are going to assume that we use, for example, the state variable x1 until x3. Okay, so not good explanation. Let me just write it. Okay, just write it out. This one. Okay, what we did first one is cross multiply, right? So cross multiply. So you have C as multiplied by S squared plus A2S squared plus A1S plus A0. Okay, equivalent to B0 RS. Okay, then you use the inverse transform, you get C double dot, okay, plus A2 C double C, ni bukan double dot, triple, plus A1 C dot plus A0 equal to B0 R. Right? So when you have this, okay, this example, okay, so what you do is that you are going to actually denote the, okay, define the state variable. Okay, so define the state variable. Let's say we define it by x1 equal to C, x2 equal to C double dot, x3 equal to C triple dot. Okay, so we want to get in the state variable, right, in terms of the derivative of this x1 until x3. So you have x1 dot equal to C dot, which is equal to, what's the variable? Oh, C dot and C double dot. So C dot is equal to x2, x1 dot equal to C, x2 here equal to C dot, got C double dot, which is equal to x3, x3 dot, which is this one, is C triple dot. Okay, so once we define that, okay, number 3 is define it. Number second tadi just now was to inverse the Laplace. Okay, so you just refer to here lah, in the slide. The slide, okay, actually slide 2, select the state variable. So you select the state variable, and then what you're going to do is that, like what you did in the example before, is that substitute this state variable, okay, into this equation, right? So let's say that just from here, so C triple dot is x3 dot equivalent to, equivalent to, okay, before we continue with x3, why x3? Because if you see here, x1 dot is already x2. You have already solved this, right? x2 dot is equal to x3. You already solved this. How about C x3 dot? No yet. So that's why we are actually substituting in this equation. Okay. So x3 C triple dot is x3 dot. x3 dot plus A2 C double dot is X3 C double dot X3 plus A1 C dot is X2 plus A naught equal to B naught R. So R is what? R is output, right? So if you look at this equation, okay, you can also define your output on the right hand side here. Okay, so output is what? Y equal to C, right? C, right? Y, C, this one lah. Okay, Y, don't go, if you get confused, then try to draw the block diagram. Okay, so G, output is C, because you have C over R, right? And then you have R, then output is C. Okay, so C is what? C equivalent to, we have C here, X1, right? So X1. Okay, this is output. How about input? Input is R, right? So input U equal to R. Okay, so actually this B not R is, you change it with U lah. Okay, U. So now you have completed the third equation. So we represent it in the state equation and output equation. So state equation x1 dot, x2, x3 dot. Okay, what do you get? X1 dot, where is it? X2. So x1 dot is here. So you have x1, x2, x3 plus the input U. So x1 equal to x2. So you have 0, 1, 0. No input. X2 dot is equal to x3. So 0, 0, 1, 0. X3 dot is equal to C. Do you get the answer? Yes, we get the answer over here, right? Okay, we define it, but we didn't finish rearrange it yet. Okay, tak sabar. Okay, no patience, people say, no patience. Okay, so x3. So write that equation x3 dot equivalent to what? Minus, sorry, B naught U minus A2 x3 minus A1 x2 minus A naught. So now you have the third equation x3 dot. Okay, so x3 dot is B naught U, so B naught. A1, x3 we have minus A. Okay. Correct this one. Kan? Yes. Minus A2. Sorry sendiri gila. Minus A2 Okay, x2 is minus A1. Minus A1. Do you have x1? No 0. Okay, so let us check with the answer. Sekejap Ke ada tersilap ni? A naught mana Oh ya. A naught x1 I think tinggal lah. Atas ni kan tinggal kan? X1 kan S1 A1 X squared S. A naught, right? What was missing? What was missing just now? C. You forget about the C here. A naught C, right? Because of A1 A0 here. So my bad. Okay. So A naught, you have A naught C. C is x1. So basically you have x1 over here. Okay. So this is minus a 0. Alright. So let's look at the answer. Is it correct? It's correct, eh? Let me just take that answer. Okay, this is the answer. Right? So almost finished. Right now, you only have the state equation. Okay, you haven't write out the output equation. So y equivalent to, where's the output equation? Over here. You have x1, x2, x3 plus 0. Okay, so output is x1 only. Okay, so 1, 0, 0. Done. Okay, so what we did was to actually confirm that the answer is correct, no? With the, well, actually this one is just the theory behind it, but I try to solve it for you guys, so that it's easier for you to understand why actually come up with that answer. Okay, so this will be another example whereby if the numerator is not a constant value, okay, you have in terms of second order system on top of here. So if you learn about signal flow graph, so you can actually split the signal, put into two, right? So you have the first equation with the numerator, and then you have the second for the numerator. Okay, so if you have that, the state equation will be the same. Okay, but the output equation will have 3 output, and you can come up with this y equal to b not b1 b2 over in the x1 x2 x3 state. Okay, so try to do it at home. I think this is simple. Try to denote it, okay, using the same variable. Okay, this one is one example because we don't have time. Okay, and I give you the answer down there. So verify that the answer is what is it? Okay, so you can verify this answer whereby, okay, you find the state representation using the same method just now. After you get A, B, C, D, using MATLAB confirm that the answer is correct. You can get the transfer function. So if you get the transfer function, it's correct. Okay, we don't have time, so you can do this on your own, a very simple exercise. Okay, so as assignment 2, okay, what you're going to do is that you're given this equation. So I'm refer to the textbook. Ada kelas. Refer to the textbook. Okay. So in the textbook, this equation, this question is in the textbook. Just that have different value lah. I'm going to denote it with different C and D value. So the question 1 is that find the state variable represented by considering the two mass system. Suppose the parameter of M1 is given by this value. So what you need to do is that first come up with the differential equation and come up with the state variable A, B, C, and D. Okay, and then express this at the state variable model. Then you can verify your answer using MATLAB. Okay. Number 2 is that compute and plot the free response of x1 and x2. Means that what? You have a two system like this. Example, for this case, two system x1 and x2. x1 and x2 is a response that's going to move depending on the input state. So in this case is that you're given the input state for x1 at initial state is 5. Okay, it means that displacement at initial is 0. Okay, and the velocity is -3. It's given by that. Okay, means that there's no displacement, but they have a velocity over there. Okay, and x2 is 0 and x2 dot is 2. So you using the following matrix ID, okay, analyze your result and summarize the impact of increasing M, C, and K parameter to the system using simulation. So even though this value is given by M1, M2, and so on, so what I want you to do is that to vary the parameter of M. Example, M1. Okay, by having the other value fixed, Okay, increase the value of M1 and see what is the response of X1 and X2. So means that response you have to plot the graph. Okay, and then go to the next one. Okay, you are going to vary M2 value. Okay, and see what are the response to the parameter X1, X2. And change the value, the other fix it M1, M2 and C2 fix it. Change the response for C1. So you can have, now you can actually make an assumption. Before you do the simulation also you can actually make assumption whereby C1 effect is what? C1 effect is a damping. So it's going to give you a high oscillation or low oscillation depending on the damping coefficient value. But you still will go to the same steady state. Alright? So do that as a assignment. Okay, define your own parameter. So it doesn't mean that each student need to have the same parameter. So you can do a variation whereby you can make an interval of the value 0.1 difference, or you want to make the value for M1 is 5, 6, 7, 8. At least minimum 3 variable. You vary for each parameter. Okay. How to do this? There's a instruction in the textbook. So you need to download go to the library and refer to the textbook. Okay. Okay, the assignment submit by 1 December. Like I said, 1 December, both assignment 1 and assignment 2. And I think that will be all for my class. So as a reminder, we have midterm exam on 15 December, 15 December, which is on Friday, is it? Friday, 9:30. 9:30. So it will be 1 hour. It will not cover state space, meaning that you will be given an equation, a system. Example, let me just open the tutorial. Okay, so not this one. Okay, this one. So in the tutorial, you will see that I'm not giving you a free body diagram at all. I'm going to give you a system. For example, the door, okay, seat with suspension system, whereby I'm not going to define where is the parameter M1, M2, C1, K1, and so on. This is based on your understanding of the system. Okay, so for level master, the moderator said that you cannot give student the block diagram. Student need to come up with their own block diagram based on their understanding. Okay, so example like this one, the door. How do you do the modeling? Okay, for the chair, okay, the seat with the damping coefficient. Okay, for quarter car suspension system. Okay, this one I think it has been used in the class. Part 2, I have used most of it. Quarter car suspension system. Okay, and then we have the tutorial 4, 5, 6 is on circuit. Okay, this circuit will be the one example that I showed to you, only one looping. Okay, this, if you see here, even though there's 2 looping, it doesn't mean that it's going to be 3x3 matrix. What was the tips just now? It's based on the energy storage component, right? So how many can you see? 1 and 2. So you will have a 2x2 matrix. Okay, so another example like this. So how many can you see? 3. You have inductance, you have 2 capacitor. So you will have a 3x3 matrix. Okay, same goes to this one. So you have 3. So it's going to be a 3x3 matrix. Okay, so make sure that you go to ULearn and view how to do the 3x3 matrix. Okay, maybe in the exam we come out 3x3 matrix. What's exam? We cannot give you a easy example exercise. 2.2 2x2 is kind of easy. So it might go up to maximum 3x3 only. 4x4 impossible for you to answer it within the hour. Okay, so that will be all from me. After the midterm, your exam will be week 9, I think, week 9, 15 December. So week 8, after the midterm break, Dr. Khairi will take over the class. So I hope that will be I'm not sure if I'm going to do a revision class. If there is a request, then I will do the class. If no, then that will be the complete lesson from me lah. Okay, then we will meet again during midterm exam, and also midterm exam will be held here, and then on during the final exam. Alright, so that'll be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.